Measures of dispersion. These are the statistics that tell us how the data set spread around the center of the distribution. So the first year we're talking about the range, that's the highest value minus the lowest value. Then we can also talk about the interquartile range. The interquartile range. The quartile range is the third quartile minus the first quartile. Then the mean deviation tells us on average how far all the values are from the center. We'll take examples and see how we can calculate the mean deviation. And the variance is the average of the square of the distance each value is from the mean. Then the standard deviation is the square root of the variance. If you know the standard deviation, then you can find the variance, because this is how they are related. One is the square root of the other. The square root of the variance is the standard deviation. So we shall look at how we'll solve this. Shall look at how we can compute the standard deviation using examples. Let's take our very first example. The table shows the distribution of marks scored by students in an examination. Calculate correct to 2 decimal places the mean and the standard deviation of the distribution. So we construct a table that will help us to calculate the mean and the standard deviation. So we find the class midpoint by finding the average of this. So 60 plus 64 will give us 124 divided by 2, that will be 62. Now repeat the same process for all. Now the next thing we do, so we multiply 2 by 62, 3 by 67, 6 by 72 in that order. Then we obtain something like this. Next, there is x here, there's x here to multiply this column and this column to obtain fx squared. So 62 by 124 will give us 7688. Same process for all. So we found the totals to be these values. We sub them into the formula to find the mean. And this will give us 78.5. Now the standard deviation, so the standard deviation with the substitution of the values into the formula, and when we simplify we get 7.95 to 2 decimal places, and the mean is 78.50 to 2 decimal places. The table shows the distribution of the masses of some bags of beans in a grain stores. So here is the table. We are supposed to calculate correct to one decimal place the range and the mean deviation of the distribution. So let's start. Now let's quickly draw the table. We need to find our class boundary. So this becomes, we subtract 0.5 from the lower class interval over here. So we have 50.5. Then we add 0.5 to this to get 55.5. We repeat the same process until we get all the class boundaries. Next, we find the class midpoint. The class midpoint is found by adding the lower class interval to the upper class interval. So 51 plus 55 will give us 106. 106 divided by 2, and that will give us 53. So this space will be 53. So repeat this for all to obtain so we find fx that we're multiplying the frequency by the class midpoints. So to obtain 371. So repeat the same process to obtain all this. Then now we'll find the absolute value of the deviation. Now we need to determine our mean first. So the mean is given by sigma fs over sigma f. So sigma fs, we need to find sigma fx, summation of all this, and that will give us 3095 rather. Then the sigma f, which is the summation of all the frequencies, is 50. So now the mean given by x bar is sigma fx. So we have 30,905 divided by 50, and I think this will give us 61.9. So now we'll find the mean deviation, the absolute value of the mean deviation. So we have 53 minus 61.9, and that will give us negative 8.9, but the absolute value is positive, so we have 8.9. So we do the same thing to obtain all the mean deviation, the absolute value of the mean deviations. So let me go faster. So we are going to get Now we multiply this by f. So 7 times 8.9, that will give us 62.3, and we do this for all of them. So we find the summation of all these now, and that will give us 202.6. So 202.6. The range is given by the difference between the upper class boundary of the last class and the lower class boundary of the first class. So that is going to be 80.5 minus 50.5, and that will give us 30. Then the mean deviation is given by this, that is 202.6 over 50, and that will give us 4.052, and when you run this to 1 decimal place, and this will be 4.1 to 1 decimal place. Remember that to calculate the mean deviation for raw data, you use this formula. Then for a data with frequency, or in a frequency distribution table, you use this formula. Then the standard deviation can also be calculated using these three formulae. Now the first one is for raw data, this one is for the frequency distribution, and this one too is for the frequency distribution, but this one is we are using the deviation about the mean, the deviation about the mean.